I'm going to do number 22 out of the book. And we're told listed below are the amounts of caffeine in one can of each of these 20 brands. And they list a bunch of different brands here. They've got a couple listed here. Use a confidence interval of 99%. Does the confidence interval give us a good information about the population of all cans of the same 20 brands that are consumed? Does this appear to be normally distributed? If not, how are the results affected? Okay, so first thing is you need to put in this data. So if we're going to do this in StatCrunch, your first job will be to input the data. And obviously, if you're doing this in My Stats Lab, you can a lot of times import it straight in or even just download it into Excel and copy and paste it. Okay, once it's, and I'm going to just, because I'm going to label that, but we have our data and that's your first thing. Now to get a confidence interval in StatCrunch, you're going to go to Stats, you're going to go to T-Stats. So I want a confidence interval of the mean. I don't know the population standard deviation, so I need a t-test. That's why I'm on t-stats. If you knew the population standard deviation, you could be up here in z-stats. But we're down here in t-stats. We're one sample, okay? And we have data. So now if you just had the summary stats, you would use this. But we have data, so we're going to do data. You're going to pick the column where your data is. Then you're going to click on this hypothesis, this confidence interval, and you're going to put in what your confidence interval is. So in this case, 99%, and then compute. So right there is my confidence interval. My confidence interval goes from 19.54 to 45.56. The standard error, though, is not the E. So if, for instance, if you were doing your project, this would ask for E. To find E, what you're going to do, okay, you can do it, not that. To find E, what you're going to do is you're going to take your sample mean here. So here's our sample mean, 32.55. Okay, and the reason you're going to take that value is because that value is going to be plus or minus that. So if I take 32.55 minus 19.54, have to put in the right value, then E is 13.1. I can do it same from the other side, 45.56 minus the mean. Oh gosh, I don't even know what, okay. Now it's really mad. Okay, clear. Okay, minus, you have to be able to type, and obviously that is not one of my skill sets at the moment. 5. There we go. And you can see this is the same 13.1. You should get it either way. So if you need the E, because you were asked for it in the question or whatever, it is not the standard error they gave you, but you can find it using the limits and the mean they do give you. So that's your kind of thing. But here is your confidence interval. So this would be a 99% confidence interval about the mean. Now the rest of this question asked us, does this give a good information about all cans? Well, the problem is that these brands are not consumed with the same amount. So more people probably drink Cherry Coke than drink Tab. So that wouldn't be a good overall population one, just to use one of each. And because of all the zeros, this is not normally distributed. If you put this on a Q plot, you'd have a disaster. Or if you tried to make the histogram. So is this a great confidence interval? Probably not. You'd probably be much better off to look at specific brands or look at drinking, how many different people drank different cans and see how much caffeine is actually being consumed.